Welcome, everybody, to our last and final here at our Automate show. This is a live session. I want to make sure that our attendees are aware that you guys could ask questions during this session, and we'll do our best with the panel to answer these as they come up. Our topic for today is linear and rotary positioning, and essentially what is the best way for your application. My name is Luke Kiesel. I'm the Western District Sales Manager for Destaco. Our panel of discussion, or people that are going to be attending our discussion here, include Ravi Shivana, Global New Product Development for Engineering for Destaco Camco Products, Ray Tinchek, Applications Engineer and Manager for the Destaco Camco Products. We've got Jay Goldberg, VP of Sales with Goman and Sella, and Tom Duffy will join us here shortly. First question I want to ask the guys here, in this wonderful world of automation, is there a shift in the industry that we're seeing? Is one maybe more favorable than the other? Do customers see maybe the linear or rotary to be the best way of approaching an automation system? Jay, what do you think?
Well, I think if you had asked that 5 years ago, I'm seeing right now, I'd say a 50-50 split with rotary versus linear, especially when you're talking about bigger applications. A lot of it has to do with where a customer is going to fit this into their factory, how they want the operators to interact or not interact with the machine. I would say, I don't know that I'm seeing. Well, I guess it would be a shift. Yeah, I think it was rotary for a long, long time, but linear has really come on strong, and I'd say it's about a 50-50 split now for these larger applications.
Ray, any thoughts?
Yeah, I think years ago, rotary indexing was all the rage, but as people started seeing the benefits of, not only is it a better use of floor space, arranging some rectangles basically, you could also fit a lot more stations on any one given machine. So, there's almost no limit to how many stations you could put around a linear conveyor, as opposed to trying to fit a large number of stations in a circle. So, there's definitely been a large jump in the number of conveyors that we're seeing.
Essentially, I think it's.
And actually, Luke, do you mind if I jump onto something that Ray hinted at there? I'd like to add to that. One of the things that I've seen our customers doing, especially with the conveyor systems, is they will tool up 3 different stations, up to maybe 2 to 3 different stations to do similar products, but just different enough that they would have to come in and change all their tooling if they did that. And what they do is they just index to the station that they want, and then the conveyor goes. So we've instead of having a rotary where you've got your fixed stations, and if you need to change something out, that's a mechanic coming in, they can actually just add stations to a linear, normally using a servo, go to the station that they want, and then skip the stations they don't need. And that has offered quite a bit of flexibility.
Actually, you bring up a great point there, Jay. I think with maybe the industry shifting a bit, the term flexible indexing, comes to mind. Can you guys maybe talk about some of the advantages versus, mechanical versus servo, as that kind of obviously pertains to what you were just saying?
So mechanical, I would say the greatest advantages of mechanical is just its repeatability and the accuracy. I think you guys talked about that earlier in the day, but it's just going to run its entire lifespan, however many years, 20, 30 years, it's going to do the same thing over and over. It's going to hit the same stops over and over. And that's perfect for a line that is never intended to change. It's with very minimal maintenance, it's going to run for a long, long time. And I'd say those are the significant advantages of a mechanical system. We are also talking servo systems now. We're getting a lot of customers are asking to put servos on these, and servo gives you then more flexibility. It's a little bit more difficult in the programming realm. It's not just running an AC motor like a mechanical system. So it does require somebody to actually program it and understand how they're doing that. But it does give you that flexibility. Going back to what I talked about, if you have 3 stations, just within the program, you just select it's going to be the first station or the second station or the third station, and then it just runs. That is not something that is easily accomplished with a mechanical system. So we'd like to look at each individual application as they come up. The salespeople are the first line of defense. We go out and talk about all of the things we've already talked about. What's the space? What's the best use of this? How fast do you need to go? What does your stuff weigh? Almost all of us then bring Ray in and start discussing the application from a very detailed technical standpoint. So it really just comes down to we take every single application. We don't try to make any assumptions as to what would be best until we hear everything that they want to do. And sometimes it turns out that the mechanical system that's got stops built right into the cam is perfect for the application. And other times it turns out that servo would be the best.
Ray, any thoughts?
Yeah, at first when servos first came out, they became popular really quickly, and everybody was jumping on the servo bandwagon. But then they started also seeing the complexity and the cost associated with it, and there's been a little bit of a resurgence of going back to fully mechanical systems. And many of our applications, they don't have variable strokes, and they just repeat the same output over and over again. So mechanical system is still works, and we can even still drive a mechanical system with a servo motor if they just want speed feedback or process feedback. That's kind of what we're seeing also now too. A lot of is using our fixed stop indexers, the rigidity. You don't necessarily have to have the same inertia matching as you do with a full servo system, because your mechanical part of your cam is taking care of that. You just need to control speed. So we are seeing in some of our machine builders, there are some out there that's all they make is fully mechanically tied systems where they say when we set something up, we want to fire it up and just forget about it. We don't want to hear anything else about it. And they work very well. And I know, Jay, you've got customers, machine builders that's their mantra.
Absolutely. It's the cliche of the person out in the middle of nowhere that's got a little thing, filling cartons, and they don't want to have anybody who knows anything about servo programming, and they want to just turn the motor on and let it run. And then you've got the people that actually have full maintenance departments and full engineering departments that the servo system might serve a little bit better. So again, it all comes down to working with the customer from start to finish. What is the best? We come to that conclusion all together. What's the best?
And it seems like there's a fit and form for every customer. And it all depends on their comfort level, the complexity they want to go with, and how tech savvy they might get. Now, when we look at linear versus rotary, Ray, you did mention that floor space sometimes is something that should be at least something that the customers are thinking of. Is there one or better method of doing things? Is having maybe multiple indexing devices versus having one linear form? Is that a better form, or is it more application driven? How does that work?
Well, yeah, I mean, if you've got a lot of stations in your process, and say it would take several rotary indexers to accomplish all the processes, you would have to hand off from one to the other to accomplish these tasks. And whereas a linear indexer or conveyor, there'll be far fewer handoffs. Than you can accomplish the same thing with just setting up all the stations around the perimeter of the conveyor.
When we look at floor spacing and forms of doing linear versus rotary, we have a question that just came in. Maybe Jay, you could help me answer this. Do machine builders, do they favor one over the other system on an OEM level and also on an end user level? Is there a preference possibly?
Well, I'm seeing a question that came in about the little floor space. It really comes down to what you have for floor space. A ring drive does what it does very well because you can mount stuff on the inside of it coming to the outside, and that saves a lot of space, but it still is circular. So you have to have space for that. You have to have if you're going to have operators interacting with it, they have to have enough space around that unit to be able. And most of our ring drives are, I don't know, I'm holding my hands up here, but they're fairly large. I mean, so they do take up a good diameter of space within a good area of space within something. I would say when we're starting to talk about a lot of stations, that linear really starts to come into its own because it can be thin but long. You can get operators into it very easily. You can expand it as long. One thing you can't do with a ring drive is expand it if you need to, but we can have a conveyor anywhere from 3 feet up to, I think, well, the most I've seen personally is about 15 feet, but I know we go beyond that. I know we do. But that was because of the amount of stations. And if, that took up a 15 foot by about, I don't know, what, 3 feet maybe wide. Whereas if we had to do all of those stations with rotary, it would have been a very, very large proposition. So linear starts to be, as you start talking with customers about what they want to do, the answer does kind of present itself kind of self-explanatory. As we start talking about how many stations you've got and where do you want to put them, it just kind of coalesces, and eventually it just makes sense. Whichever direction we go just kind of makes sense.
Understand. Ray, when we talk about work environments, there was a question that came in from our group here. Do work environments affect the performance of one versus the other? Let's say if it's a dusty environment, gritty environment, do we tend to lean customers one way versus the other, or can maybe both systems act and perform the same way? Can you maybe speak about that?
Yeah, in the nasty environments, it's probably easier to prepare and shield a rotary indexer than it would be a linear indexer or conveyor. The conveyors have open track designs, and they're much more difficult to seal up than it would be a closed indexer. We could use double seals or put shielding around it, and you won't affect access to the part that's indexing. There are some things we can do to protect some of that, but I would think in general the rotary indexers would be easier to protect in the bad environments.
I agree. It's a sealed system that obviously you don't have any grit coming inside of an indexing device. There's ways that you could definitely shield it, especially typically it's a dial application. So you have a fairly large dial that you're putting on top of the rotary or indexing device. So obviously that's another form of protection. Jay, were you about to say something there?
Well, I wanted to offer a real world example if I could. I got to be careful. I don't want to give away any secrets, but we have a customer that makes disposable toothbrushes for the hospital industry. And part of that process is putting the grit on there that turns into what you brush your teeth with. And it's extremely caustic. It's very gritty. it gets everywhere. We're using conveyors there. I have seen our conveyors packed with that stuff. It's just white powder that you could sand something with, and they're still cruising along. And they do try to, you know, blow it out every once in a while. But I've been over there and seen it just packed with that grit, and it's still going along. So it's a good question. Paper dust, welding grit, what have you. It is something we want to take into account. But we have examples of this stuff being in some very heavy industry, and it's doing just fine.
Yeah, you could do things, you know, using air pressure, vacuums, that kind of thing, and sometimes the orientation of the conveyor over and under, as we call it, or a carousel, can be, you know, treated differently as well.
One thing, and I don't know, Luke, if I'm jumping ahead to something you wanted to mention, but since we've already been talking about servos and the linear, I wanted to give another real world example of how fast we can move these things. So if everybody could kind of picture a 15-foot long conveyor with about 12-inch links. So we're gonna index 12 inches. This with a servo system. Every single link. So I should have done this math, but the 15 feet divided by 12. Every single link was about 13 pounds. Had about 13 pounds on it. So quite a bit of weight. We were able to do that 12-inch index from dead stop to dead stop in 0.29 seconds.
It's pretty impressive.
Which I find mind-blowing that we can move that quickly with a piece of mechanical, moving that much weight, that much inertia, and just do it 24/7, over and over and over and over. That is such a fast rate. That's where I really got my appreciation of what our conveyors do.
Look, before I think we move forward to one of the other question, I think we had one question which we actually maybe we skipped it. It says, what works best with a little floor space? I think to answer that question, you know, it could be either our indexers, the regular indexers, which can actually work with the little floor space for sure. The floor space is relatively, you know, if it is very small, we can also design a small conveyor with a very small center distance, and we can also have a precision link conveyor working in that floor space. So the best answer to that is, you know, indexers and precision link conveyors can both work in a little floor space. We need to understand what that little floor space is.
Correct. Now, going back to, you know, if we could step back a little bit into history, Camco, the brand name, I always like to say it's the staple in the industry. And it's almost as comparing Kleenex to tissues. Whenever I visit customers, you know, that's the first thing they say. I've got, you know, I want to put a Camco in, and you know, the first thing that comes to mind for us, we know what that means. They want to put an indexing device in there somehow. Or I've got this Camco that's working for 20 years. You know, I need a little bit of help, maybe changing the oil. First thing comes to mind, it's an indexing device. But you know, over the years, Ravi, maybe you could speak to this. Has Camco traditionally been known for indexers or known for a conveying system? Has that maybe changed over the years? How do we start off into maybe that you know, transition a little bit?
I think traditionally when this Camco started, it was mostly about, you know, very prominently building mechanical indexers, and slowly it started building in servo-operated, you know, indexers. Very lately, maybe in early 90s, we started manufacturing about this precision link conveyors. So more popularly today, both mechanical indexers, I would say three of them, the mechanical indexers, the servo indexers, and the precision link conveyors, all of them stand in the same place in the market, wherein they look for solutions with Camco, Distaco for any of these turnkey solutions. Not only that, Distaco is one of the, you know, I think a major indexer or precision link manufacturer company, wherein we actually build up the packaging solutions to the customer, where we offer the indexer, motor, and also the drive package to actually run this indexer in one-stop solution. So this could be an asynchronous motor with the drive package, or a DC motor with the drive package, or even our servo motor along with the drive packages, which is supposed to go to actually drive this indexers and also conveyors. One of the other important product which I think Jay mentioned earlier is also about the ring drives. The ring drives by itself are called as the rotary conveyors, wherein you can do a lot of space saving just by having one of the ring drive and having the robo placed in between the space available in the ring drive, and work inside out rather than working outside in, with space which saves a lot of space for the customers.
I would say the ring drive is the rotary equivalent of a linear conveyor. When you're talking about our other rotary devices, I think those stand on their own. But the ring drive, I've always kind of, the way it's laid out and the way people interact with it, I look at that as a rotary version of a linear conveyor.
Ray, quick question on your side. When we come to the discussion of maybe accuracy between rotary indexing versus linear indexing, is there a difference between both of those? Can you maybe elaborate a little bit on that?
Yeah, I mean, both are precision devices. Our conveyors are traditionally run by rotary indexers, so its accuracy depends on the rotary indexer accuracy. Both offer precision. So obviously, if you're going to drive a conveyor, which has its own inherent accuracy with a rotary device, it isn't going to be as accurate, but still, I mean, our linear conveyors, our standard accuracy is like plus or minus 0.005 of an inch at any station, and many times even better than that. So it is definitely not an imprecise device. So I wouldn't say there's for a precision process, I wouldn't say that I would have to consider one over the other strictly from an accuracy perspective.
I guess where I was going there, our conveyors are traditionally driven by the same index drives that we manufacture for rotary indexing applications. So, like you said, the precision is typically machined into our devices. Now, if we go into servos and those forms, obviously we use more of a technological approach to put in the accuracy in there. I just want to remind everybody in attendance that we do have a poll question that's going to be coming out there your way. Please chime in and then get us your feedback. I appreciate that. Ray, if you could, talk about a little bit about maybe over the course of the few years, how did the industry is in your eyes is changing a little bit? Are they going traditionally towards rotary indexing or conveying? Have we seen an increase in one or the other?
Definitely, yeah. I mean, years ago, like you have mentioned, that people referred to Camcos, they were referring to a rotary indexer.
Correct.
We've had conveyors, a conveyor product for just as long. So, and then I'd say within the last 5 to 10 years, there's a very significant spike in linear applications, and I think it's a combination of floor space or ergonomics, but also I think process engineers and machine builders are trying to optimize their processes, so fewer handoffs, more stations in under one device. So yeah, linear indexing is definitely really boomed over the last 5 to 10 years.
I'd agree with that.
Next question that we want to maybe hit, or a topic here, is there a life expectancy? What's the longevity of maybe one form versus the other? Conveying versus rotary indexing. Is there a certain lifespan of one or the other? Jay, can you hit on that maybe?
As far as I can tell, they both last a really long time. When we're sitting down to do the engineering study, we want to make sure that these are oversized. That's one of the things we do. So we want to make sure. The reason we want to make sure that it lasts for a long time is that we realize that we are buried in the heart of a machine. A conveyor, if there were to be problems with a conveyor, it's very difficult to get it out, to get in there to maintain it or to get it out. So it needs to be built like a tank, and it needs to last a long time with just basic maintenance. Same thing for a linear index, a rotary indexer is usually, you almost can't even see it. It's buried within the heart of the machine so much. So I've been with Camco for about 8 years now, and I've been out in the field and seen devices 30 years old that if they change the oil, maybe every once in a while, they'll do that, but it's still cranking along, it's still running along. So I would say both of them are built with an eye toward longevity, because we do realize where we are in a customer's machine and what it does should there be a problem.
Yeah, it has to be sized conservatively for all the reasons that Jay said, and we take that approach from an applications perspective. We push really hard for as much detail as you can give us with the load and the application, and even if we're at a ballparking stage, we stress very much to come back when you've got your design finalized. We do have to size conservatively for those reasons. We do not want to have to have a customer tear apart his entire machine just to pull out the indexer from the center of it.
I'd say the only time we redlined everything was that application I referred to earlier, where it was 0.29 seconds. The only way to get that was to just go for it. So normally we'd have a lot more room in there for, I don't know. That one was pushing the limits of what we can do on a conveyor, but most of the time it's an oversized application.
Yeah, and I think when it comes to accessibility to the machine itself, both of you guys mentioned that we're in the heart of the machine. I've heard that term many times, and you tend not to want to do any surgery on a heart if you don't have to. But I think when it comes to maybe retooling or repurposing something, at times I think the linear form is a little bit easier to do. I mean, you do have the link chain itself, maybe the fixtures, things are a little bit more accessible. Jay, as you mentioned, we've even personally seen machines that are embedded in the machine that you barely see, the indexing device even moving. So you guys have great points there. I want to remind everybody that are part of the call, if you could please submit any questions that you guys may have. I'll do my best to put those into our discussions as best that are fitted. So just want to make sure you guys are staying involved and appreciate your assistance there. Another topic or question that we want to maybe hit on is, what are the ranges of capacities and sizes of our conveyors and indexers? Jay mentioned that there's, sizes that he's been working that are 15 feet long, but are those our limitations? Ravi, can you maybe touch on that?
Sure. So with respect to indexers, we offer wide range of sizes of indexers and also on the conveyors. If you talk about or want to name about a few of the indexers which we are offering today, it could be miniature roller gears, which has a capacity of 86 Newton meter to 2085 Newton meter. And we have some parallels, about 4 sizes, and right angles of 3 sizes, which actually drive these conveyors. We have the roller dial mechanical indexers, which is about 6 sizes, and heavy duty RD sizes and other heavy duty E series indexers, which I would say we have a range of indexers which can serve for various requirement of the customer needs, ranging from very small torque requirement or the axial load capacity to very large axial load or the moment load capacity, which can go into automotive world. What is more important also is the accuracy part of it. We also serve, from the largest indexer, we could be, somewhere at plus or minus 8 arc seconds to smaller indexers, which could be around plus or minus 60 arc seconds. So wide variety of indexers that is being offered to the customers with a wide range of accuracy requirement. We also offer special accuracy needs. We also meet special accuracy needs for all the customer requirements. One of the other important thing, which also I want to make sure I add to this discussion, is Camco is one of the global leaders in manufacturing any of the custom motion. That is custom cams, either it is a 2-dimensional or a 3-dimensional. So we cater to a large variety of requirement for this custom cams that is required in the industry. We do actively work with our customers to develop custom profiles, custom motion profiles in the industry. So coming back to the range of capacities with respect to conveyors, I think we limit the precision link conveyor, modular conveyors link to be loaded at the max, which would go per link load would be around 25 pounds, and the center distance it can start anywhere between 52 inches or even a little smaller, or we can go up to around 300 plus inches. So typically we would limit our the length of the conveyors to around 30 feet, and above that, we want to offer the tubular conveyors up to 40 feet. Okay. That's kind of small and the larger ranges which you can offer with conveyors. We can also work with heavy duty conveyors which can handle very, very different or high capacity loads that is required for the customers with respect to any of the heavy duty indexing or the conveying that is supposed to be done.
Ray, any thoughts on that?
Yeah, that was a great summary there, Ravi. I think in general the rotary indexers probably can cover a much larger range of loads, from the lightest weights to ounces or a couple pounds to thousands of pounds. Centralized load and also station weights. But conveyors, once we start getting like the 25 or higher pound range, we start taking a much closer look at how fast you want to index these things, how far off the face of the link the center of gravity is, and those kind of things. But yeah, I think in general the rotary indexers have a much greater range of, especially when you start getting way up high in the weights. Like I said, thousands of pounds, hundreds of pounds. We've got a very large product range that we can cover just about anything.
Jay, can you maybe talk about some examples of conveyor systems? I know you brought up that one. Any others that come to mind? Things that maybe you've worked on in the recent past here? Any fast application, anything like that?
Well, the fastest one I did is the one I've mentioned. Mm-hmm. That one was really cruising. I can't say what that product was due to secrecy, but we have also put together manual or transmissions for cars using linear. We are inserting needles into syringes in certain applications. So going back to what Ray was talking about accuracy, I mean, if we can get a needle in the same spot every single time to put it where it needs to go, we've got really, really good accuracy on that. Lots of food. We have big conveyors in Nestle, which makes the instant coffee. That actually is, going back to the grit question, that is the stickiest stuff I've ever come across. You go in there for about 15 minutes, you come out and your eyes are sticking together. And we had to play around with that a little bit, but our our conveyor's still making it through that stuff. So
good. Now, when we
basically any industry, Luke, these would fit into anywhere.
understand. Now, when we look at, I guess in the recent past here, I've ran into applications where traditionally indexing devices or conveying systems, you would think that it would be more of a dedicated system. With the industry changing, people want to automate not only the high moving items or the high volume items, but they're also wanting to automate the lower volume items. And I think this is where flexible indexing comes into play. I know that we're going to have a discussion about this tomorrow at our last session as well, but I just want to hit a little bit on that, Jay. Do we see customers using that to our advantage, or maybe utilizing a linear form, and maybe putting every other link a different product so that you could use the same system but running it with a servo motor? To pretty much, obviously utilize that same machine with multiple products then versus a dedicated automation?
Yes. In fact, that is a real world example where we have a customer that has 3 different tools lined in a line, and then they keep repeating that. I think it's about and rather than retooling for the new part that they want to run, they just use a servo and say, okay, we're going to run part number 2 today. So before it starts to move, it moves into position where it will be now. Every time it does its index, it'll come up to the second one of those in the line. They want to go to number 1, they do the same thing. And that is what a servo, that's the flexibility that a servo allows you to do. It allows half moves. It allows, we can always go backwards, but back and forth, whatever you want to do. It also allows you to repurpose. If you get a 4-stop indexer, you've got a 4-stop indexer. If you want to repurpose that for 6 stops, that's not an easy proposition. You can do that with a servo. It's very easy to repurpose. Now, how many people repurpose? Because these things are usually, again, they're built to last. So they're customers that are putting this into a line that they're expecting to run for quite some time. I would just say, I don't know how often people repurpose, but a servo system makes it easier to do that.
With maybe our offering with both rotary indexing and linear forms, it looks like it's a wide range of products that we definitely provide, and we hit a lot of application needs. Variety of stuff, it sounds like. Live applications that Jay was talking about there, is when we look at one versus the other, I personally can't say, one's favorable versus the other. It really is customer specific, application specific. There's a lot of things to consider. We're talking about, we started talking about a little bit about the servo stuff, but when it comes to conveyors, Ravi, I think we do offer a standard product, but we also could cater specifically to customers' needs. We have done a few special conveyors that covered unique applications, from having we called it the suitcase link. It was a very large link, to maybe a conveyor that had a hump. Maybe Ravi and Ray, can you guys talk about that a little bit? What are the other specialty things that we could bring to the table here?
Yeah, I would actually start with it. First thing is, we actually, as a global company, want to make sure we reach out to all the global customers with respect to the precision link conveyors and also the indexers with the Destaco Camco. So we offer both imperial and also the metric versions of these precision link conveyors, which actually is very important for the customers to actually mount their toolings and meet their standards in their factory with other equipments that is being operating in the floor space. So there are special conveyors, as you actually mentioned about. We actually designed many of the special conveyors actually, which can get into various custom manufacturing parts for any of the recreational purposes. Which we can talk about. The one thing which we talk about is for all of the pharma industry, we are trying to manufacture certain heavy-duty conveyors which actually can get into the measurement of I think some characteristics of the blood sample. So those kind of conveyors are also we actually built in. We also cater to the needs of industrial needs of conveyors, when it gets into the manufacturing of pistons or a few other things. So I think in a wide variety, we actually cater to the majority of the needs in the precision link, conveyor manufacturing. Ray, would you like to add anything on this precision conveyors?
Yeah, I do remember. I guess the bottom line is we're not afraid to look at any custom solution. If there's something that you don't see in our portfolio, we welcome specials and we'll consider any kind of special. We were approached one time about a manufacturer of razor blades that you think what's so complicated about a razor blade, but if you look at how tiny those little parts are, it has to be very precise, and they wanted to leapfrog ahead of competition and bump up the cycle rate too. So we were able to come up with a solution that reduced or increased our accuracy by a factor of 10. And it was an entire mechanical system driven by a servo motor, and it worked very well. We've done other things. The first servo-driven conveyor that we made is now a fairly standard offering now. So I mean, I guess the bottom line is we're not afraid to do specials, and we have done several.
Well, like I said, rotary versus linear. Once again, it's more up to the application, more of the customer's preference. We see a fit and form for both, and we're not afraid to touch and do creative things with both those versions. So I'd like to thank you guys, and thank you to